Hello, it's Mittali Kumawat from Group 319, and here I am presenting my topic respiratory pressure. So, in this topic, we will discuss about the pressures of our respiratory system. In this, we will discuss about our lungs pressure, alveoli pressures, like inhale, exhale, gas exchange, and how gas exchanges, how inhalation, exhalation process. So first we will discuss about the gas exchange. Gas mainly exchanges as site, that is called a tissue, between blood and tissue at the lungs and in the lungs between blood and airs. Mechanism of gas exchange is very simple diffusion. Now this is we will discuss about gas exchange in the lungs. Venous blood enters pulmonary capillaries with high CO2 and low PO2. Air enters alveoli with high PO2 and low PCO2. O2 diffusion from alveoli to blood down its pressure gradient, and CO2 diffuses from blood to alveoli down its pressure gradient. Next, we will discuss about the alveolus gas exchange. There is a diagram that is seen the gas exchange in alveoli. There is a one-sided show the artery and one side one-sided show the deoxygenated blood and one side show the oxygenated blood. And there is a show. Now we will discuss about the total and partial pressure. In the total partial pressure H2O in alveolar air, H2O is 47 mmHg, CO2 40 mmHg, and O2 105 mmHg, and nitrogen is 565 mmHg. So total pressure is 760 mmHg. Now we will discuss about the diagram of exchange between the tissue and alveoli. In this, the first when we inspire air, the PO2 is 159 mmHg and PCO2 is 0.3 mmHg. But at the same time, at the level of tissue, the deoxygenated blood is in the carbon dioxide is 40 mmHg and oxygenated blood is 100 mmHg, and other side is less than. Now we will discuss about the O2 diffusion. In the O2 diffusion in the alveoli, pressure is the of the PO2 is 100 mmHg oxygen level, but at the oxygenated blood side there is a pulmonary venous PO2 is 100 mmHg and deoxygenated blood had a 40 mmHg. Next is CO2 diffusion in the alveoli. In the alveoli is CO2 diffusion is also 40 mmHg, but the oxygenated side is 40 mmHg and deoxygenated blood has a 40 mmHg. And one side is venous blood and one is arterial blood. So there is a discussion about the CO2 diffusion. So next slide is factor affecting gas exchange. In the factor affecting gas exchange, partial pressure gradient of a gas across alveoli. Capillary membrane 60 mmHg for oxygen and 6 mmHg for oxygen. So surface area of the alveolar capillary membrane about 70 mm, thickness of alveolar capillary membrane about Next is diffusion capacity of respiratory membrane. So first we will discuss about definition. The volume of gas that diffuses across the alveolar capillary membrane minimum for a pressure difference for 1 mmHg. The next point is diffusion capacity increase during exercise. During the exercise, diffusion capacity is increases. Diffusion capacity increases in condition that increase alveolar capillary membrane tissue. Next is gas transport between lungs and tissues. So there is a O2 moves under its partial pressure gradient from lungs to blood and blood to tissue. Next is CO2 moves under its partial pressure gradient from tissue to blood and lung to air to eliminate. So blood carries. During the exercise, there will be a decreased PO2 in capillaries of active muscles, increased temperature in active muscles, increased CO2, and decreased pH due to acidic metabolites, increased 2-3 dpg in RBS by anaerobic glycolysis. All these factors lead to decreased affinity of hemoglobin to O2 and more release to O2 to tissues. shift to oxygen hemoglobin associated curve of the right, and the increase to 3 dpg in RBC by anaerobic glycolysis. Thank you.